Scientists have not only discovered an enzyme that regulates memory formation, but they've discovered that blocking this specific enzyme actually improves age-related memory problems, which is another stepping stone to curing, well, dementia, Alzheimer's, and a whole host of other aging-related memory disorders. So we have a sort of standard picture of an elderly person here. Let's go ahead and scroll down to the article so we can see what we've been talking about. What scientists have been studying is this molecule known as histone deacetylase 3, or HDAC3, which is an enzyme that regulates the copying of information from a segment of DNA into RNA that ultimately becomes a protein, which is important for memory formation. So it has been shown in previous studies, these are mostly just like in a petri dish kind of studies, to negatively affect memory formation and gene expression during this consolidation process. And the way that process works is the HDAC3 typically tightens up the chromatin, which is a complex of DNA and proteins, and that makes it hard for transcription to happen. And you need to transcribe in order to make these synapses change to bind to the proteins, to do the thing, the blah, blah, blah. So what they decided to do is block the enzymatic activity from happening so that it can't interfere with that RNA and DNA transcription into a protein and a permanent memory. And what they discovered in this little mice study is that mice were basically smarter. They remembered things better. They did a little test where they put a treat inside of an object and let 4 mice or several mice become experienced with it. Then they took them away. They gave some of the mice, these are elderly mice, they gave some of them an enzyme blocker and some of them not. And they put them back in the new environment with 4 objects. And the mice that had the enzyme blocker remembered that the snack was underneath the original object. The other ones kind of didn't, and they went back to bumbling around and doing their own thing. So this is hardly a guaranteed brain health. This isn't like we've solved all aging-related mental decline. We haven't, but we've made a nice step forward. Dawn Aerospace's spaceplane prototype hits transonic speeds for the first time. In case you haven't heard of this company, Dawn Aerospace is a little R&D company that has invented the Mark II Aurora suborbital spaceplane, with the idea being that, like a space truck from the 80s, what the shuttles were supposed to be, that you can take off from a conventional airport, fly straight up, go into space, come back down, and land as if it is a normal flight, or at least make it to the very outer edges of our atmosphere. Now, if you said, oh, that looks awesome, I can't wait to get a ticket on what clearly looks like this passenger jet, well, I think that this is a space plane for ants. This is very much so just a prototype right now. I like how they have the pilot out here in his pilot gear, like he's gonna fly it, but he's probably just flying remote back at the base, or just autopilot or something. That doesn't mean it's not cool though. It hit a transonic speed of Mach 0.92 and an altitude of 50,000 feet, which is 3 times and 5 times better than their previous attempts with this product. You can actually see a little video of it taking off here. I'm just gonna skip to the part where it's like way, 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 way out in outer space. You can almost kind of see the curvature of the Earth, or is that just the lens on the camera? That's a different video for a different day. But the idea behind this is that they're going to incrementally improve the vehicle's performance over and over and over again. And later this year in September, they want to climb faster than an F-15 and reach greater speeds than an SR-71 Blackbird. And they want to be the first vehicle to fly above 100 kilometers or 62 miles in the air twice in a single day, which would be extremely impressive. So while some of the online pictures might make you think you're taking a truck to space, it would more likely deliver a probe or just do a little spying or satellite work. I think the idea behind this is they build one small and then they scale it up for human use. Good news for the gluten intolerant, as scientists have finally identified exactly where gluten intolerance begins. We know it's some sort of genetic component, we know it happens with exposure to gluten, but exactly where, exactly why, what molecules, what chemicals, what genes, we're a little bit mysterious, but we have made a major breakthrough in identifying the root cause of the majority of gluten intolerance just today. So we do know that it's a domino effect of immunological reactions with genetic roots, but we're not sure about the precise chain. Well, they did a study using transgenic mice, which means some mice with human DNA or human organoids or something like that. And what they discovered is that gluten intolerance is most commonly formed with people that have a protein called HLA-DQ2.5, and some people have an HLA-DQ8. Now, what's interesting about these is they are human leukocyte antigen proteins, or the proteins that hold pieces of fallen invaders aloft, like trophies, on a class of immune cells, warning other defensive tissues to be on the lookout. It's sort of the cell that collects an invader and begins that process of creating an immune response to them. Your body does this 100 times a day. Unfortunately, these two will also grab onto and hold chunks of a gluten peptide that are resistant to digestion. I assume it's your body's kind of operating, not that it has thought, but under evolutionary logic that if it resists digestion, it may be an invader. So these proteins hold on to the gluten peptides and then instruct your body's T cells to go on the hunt for gluten peptides. The problem here is that T cells are notoriously not super accurate about what they destroy, and it triggers an autoimmune response that begins the process of creating gluten intolerance. So our big problem is literally with cells that are supposed to be identifying invaders are identifying gluten. Now, the breakthrough here, we knew roughly that. Now we know exactly what proteins to target, which means successive tests, which again, they did one here with an organoid, that's wild. But future tests could be done to modify the gene expression, to modify the protein, to suppress, enhance, to do a whole bunch of different things that might actually cure gluten intolerance. Today's first story is about one of your favorite topics, horses, who can apparently plan ahead and think strategically, according to scientists having completed a recent study on horses. We used to think that horses just respond to stimuli in the environment and can't really plan ahead or think ahead or don't have any metacognition, but as it turns out, that is completely untrue. Saying you can lead a horse to water but you can't make him drink is actually kind of reflective of their internal thought process and sophistication. A regal horse like this might not like the water in that particular creek. He might want the water somewhere else because it tastes better. Or this horse over here might just be on some sort of weird, like, cutting diet and not want water. But seriously, they are actually more intelligent creatures. What they decided to do was test this. They made a 3-stage game with 20 horses. They originally awarded a treat just for touching a piece of card with their nose. And then in the second stage, they added a stoplight. The horses were only given a snack if they touched the card while the stoplight was off. Of course, they ignored it at first, but after a couple of iterations, the team found that there was a sudden and highly significant reduction in errors by all of the horses. The horses started correctly touching the cards only when it was the right time to get the treat, which is a very specific test indicated or created to make sure that they can think ahead, that they can plan ahead, that they're timing things instead of just instantly responding to stimuli. They knew that there was a delay in a particular kind of way to do it, which suggests some at least mild level of metacognition amongst horses.